Dear students, welcome to the 6th sem class. In the 6th sem, you are going to study the DSP. Okay, welcome to the session 3. First, let us revise what you studied in the last class. In the last class, you studied about the signal, what is signal, and the types of signals. In that types of the signals, you have completed these three. But in detail, you have to study even and odd signals in this section. In this section, you are going to study about even and odd signals. And next is one example with respect to even and odd signal. And next you are going to study the periodic and the non-periodic signals. Let us begin with once again the definition of the even and odd signal that you studied in the last class also. So what is even signal? X of t is your continuous signal. X of n is your discrete signal. If x of minus t is equal to x of t or x of minus n is equal to x of n, then this x of t and x of n are called the even signal. Okay. If x of minus t is equal to minus x of t and x of minus n is equal to minus x of n, then x of t or the x of n is called the odd signal. Okay. And another one point you have to remember about this even and odd signal is even and odd signals are mutually exclusive. That is, if the signal qualifies to an even signal, it cannot be an odd and vice versa. Exclusive is nothing but what? If first time I am saying that x of t is an even signal, it should be even only. It cannot be changed as an odd. Or vice versa. That means if I told it as an odd means it should be odd. Told is nothing but what? Just we are verifying that. Okay, after verifying, we are saying that it is an even. That means even signal is always the even signal, odd signal is the odd signals. You cannot say that even signal as an odd signal and odd signal as an even signal. That is called mutually exclusive. Okay. And there could be a certain classes of signal that could not be the even or could not be the odd signals. Okay. Now see the a figure for the even and odd signal. Okay, here whatever you are seeing this signal, okay, A and B, just here you are seeing the similarities. Okay, this is the one signal, it is showing plus t by 2, this is minus t by 2, and here what is this? This is also the same 1 2, and here it is minus 1 and 2. This is called the even signal. It is evenly distributed. So that is why it is called a even signal. Next comes the odd signal. Okay, here C and D are called. C and D, what the figure shows, they are the odd signals. Okay, they are reverse. Just you see. X of t by 2 is equal to minus t by 2. Okay. Here it is 1, 2 and here it is minus 1 and minus 2. These are the figures for the even and these are the figures for the odd. Let us do the one derivation for the even and odd signal. So here what happens? We are considering the one signal, that is the combination of even signal and odd signal. And in that combination, we have to find out which part is called the even part and which part is called the odd part. Okay, so here what I have written, let us consider an arbitrary continuous time signal called x of t. And what is the object is? Object is to find the even and odd parts of the signal. Let us consider x of t is equal to x e of t plus x o of t, that is called 1.1. Let us say it is equation number 1.1, where x of e is called whatever even part of the signal x of t. X o of t is nothing but odd part of the x of t. In this equation, we will change t to minus t. We are going to get the equation as x of minus t is equal to xe of minus t plus xo of minus t. Okay, this is your simple mathematics. Let us call it as 1.2. Next, we know that x of e of t is even. We can write xe of minus t is equal to xe of t, whereas xo of minus t can be written as minus xo of t. Okay, let us take this is equation number 1.3 and this is your equation number 1.4. How you get this? This is the simple your definition of the even and the odd function. Substitute these two values in equation 1.2. We get that is x of minus t is equal to xe of t minus xo of t. Correct? You are changing that is xe of t and this is what your xo of t is nothing but minus xo of t. So you are going to get this one. This is called 1.5. Next, first we have written the one equation, that is equation number 1.1. What is that equation? That is x of t is equal to xe of t plus xo of t. Okay, that is your 1.1 equation. Adding 1.1 and 1.5. This is your equation number 1.5. Okay, that is your equation number 1.1. You add and just you simplify, that you will get in only one step. Afterwards, you are going to get 2xe of t is equal to xt plus x of minus t. In this, what is this xe of t? Xe of t is equal to 1 by 2 x of t plus x of minus t. Okay, just it is your simple mathematics. Just try to add that equation. You are going to get this. Finally, you are going to get the, what is this xe of t is nothing but it is even part of the signal. What is the even part of the signal? 1 by 2 is equal to x of t plus x of minus t. Let us hope all of you understood this. Now our next part is to find the odd part in the equation. To find that odd part, subtracting 1.5 from 1.1. By adding, you are going to get the even part. By subtracting, you are going to get the odd part. Once again, you are after subtracting equation 1.5 from equation number 1.1, you are going to get this equation. So if I wrote this x of t is equal to 1 by 2 x of t of minus x of t. Okay, here the equations 1.6 and 1.7 in discrete form. Okay, these two are the x of t when you have taken means these are the equations for the even and odd for continuous time signal. The same equation if I want to write for the discrete time means what I have to do? Only change t by n. When you change the t by n, then equation number 1.6 becomes even part of discrete time signal that I have taken as equation number 1.8. And 1.7, if I change t to n, all other parts are the same. It's named as 1.9. So the equation number 1.7 is the odd part for the continuous time signal, whereas equation number 1.9 is the odd part for the discrete time signal. It is very easy. Go through once again. You are able to understand the concept clearly. If you are not able to get this equation, you put me the command, then I will show you how to add and how you are going to get this equation. If you anybody got means put that in the comment box and in the telegram, so all are able to understand that one. It is a very easy part. It is not a difficult. all of you can able to do it. Okay, this is about the expression for the even and odd. In the examination also they can ask the derivation. And in examination they may ask the questions like this. Find the even and odd components of the equation. What is the equation? Anything equation they can give, but here I have taken one equation, that is x of t is equal to ej of t. This is one equation. For this equation, you have to find out the even and odd. So let us see how to find out that. Let us take xe of t and xo of t be the even and odd components of x of t. So then how you are going to write? So you have to take the expression for xe of t. Just now we have found, no, that is 1 by t, 1 by 2, x of t plus x of minus t. Substitute these values, only this thing. Okay, after substituting, so you in the mathematics you are going to get the one formula, e of jt plus e of minus jt divided by 2 is equal to cos of t. This is the even part of the function. Similarly, here what is the equation for the odd? Xo of t is equal to 1 by 2 x of t minus x of minus t. X of t is nothing but what? E of jt minus of x of minus t is nothing but what? E of minus jt. X of t is jt. Minus is because of this you have to take it as minus. It is equal to j of sine t. You verify these equations in the mathematics formula. Okay. So that is why what happens. This is a one x of t equation. Its even part is cos of t. Its odd part is j sine of t. Okay. So another point I want to clear you. So what I want to tell means, so here this cos t or this j sine t we cannot change. Correct? So that is why they are saying that it is not possible to say that even part is the odd part or odd part is the even part. Okay, they cannot be mutually exclusive. Okay, now let us study the another one type of the signal, that is periodic and non-periodic signals. What do you mean by periodic signal and what do you mean by the non-periodic signal? So first let us study the one definition. A continuous time signal x of t is said to be periodic with the period t if there is a positive non-zero value of t for which x of t plus t is equal to x of t for all t. Okay, so what is the continuous time signal means? Is said to be periodic with a period if there is a positive non-zero value of t. So here x of t plus t is equal to x of t, where your t value is positive non-zero value. Then this type of the signals are called what? Your periodic signals. That to continuous periodic signal. For example, you see here, and after seeing the figure, it is clear. Okay. So what happens here, 1.10, we are going to get that x of t plus m of t, that's equal to, here we are going to take the m value. For all t and any integer m, the fundamental period t0 of x of t is the smallest positive value of which the equation 10 holds. So you don't worry about this. So just I am not explaining you once again this, because when you see this figure, no, you are easy to. So you see here. So this is periodic. Why it is called periodic? 0. Here you see t, 2t, 3t. Understood? And the same way here it comes in the negative direction also. So if you want to use any numbers means, that also you can use 1, 2, 3, 4 like that. Okay, so that is why it is called the periodic and the non-periodic signals. Okay, this is called the periodic signals. Okay, this is called the non-periodic signals. Periodic discrete time signal. So that is about the periodic continuous time signal. Then what do you mean by the discrete time signals? Periodic discrete time signals are defined on similar basis. A sequence of discrete time x of n is periodic with the period n. If there is a positive integer n for each n of n plus x of n plus n is equal to x of n for all n. Okay, an example of such a sequence is given by 1.b from the equation 1.11 and in the figure 1.5b. It follows that x of n plus m of n is equal to x of n. The fundamental period of n naught of x of n is smallest integer n for which equation 1.1 holds. Any sequence which is not periodic is called the non-periodic sequence. The sequence which is periodic is nothing but it is a one continuous value where your t value is a one non-zero value. Okay, if it is 0 means we are not going to get any value there, then it should not be a period. It should be one sequence should be there. 1, 2, 3. If after the 3, if you are getting 0, then it is not called the periodic, then it is called a non-periodic signal. It should be continuous. Okay. So just now we have seen here what is that is a, like this continuous it should be there. If there is a gap here like this, then it is called a non-periodic signal. That you seen here. So here it is first they are taking as a 1, 2, it's okay. If once again if I have taken 1, okay, then if the actually heights are of the different, then it is called a non-periodic signal. Okay, periodic means continuous it should be there. Then it is called periodic. If there is any break in the simple sentence, if I want to tell means if there is any break in that or if it is non-periodic, then it is called a non-periodic sequence. Okay, and these are the reference books what I am referring, and the internet also I am referring. If you want, you can go through the different videos also for better understanding. If you have any doubts means you can ask in the comment box or in the telegram group. Why I am telling means by and whenever you are calling then it may not clear. So if you have the doubts, if you put there, then it is the question is also clear and the answer is also clear. Okay, this is one some important point about you, that is stay home, stay safe, stay healthy, and you are very precious to your family. Okay, be careful. After that, another one thing is whatever I am doing the video that is precious. Okay, so that is why go through again for your better understanding. Okay, meet in next video.